All right, so this is lesson 8.2. This is actually a pre-calculus lesson, but you're going to see the calculus connections to the pre-calculus lesson. So I'll say it again. Today's lesson is really pre-calculus, but you're going to see the calculus undertones to the pre-cal work. So before I get started, I'm going to try to have you remember a year ago in pre-calculus, maybe even in Math 3 or whatever, that when you did a unit of logarithms, that there were applications at the end, word problems in that unit that dealt with growth and decay. Some problems dealt with compound interest, that's not this. Some questions were more science or nature related, where you understood a growth and decay model doing that. And you used a formula. And we're going to see with calculus where that formula came from. In finances, the formula was A equals PE to the RT, PERT. In science, you can use the formula Y equals NE to the KT, or you can do different variables that mean the same thing, where you had a constant times E to an exponent. So we're going to see where that came from. Let's say you don't have a good memory of what happened a year ago in pre-cal. It's okay, because right now we're doing this right now. Got it? But those that were in pre-calculus last year with me know that they saw Y equals NE to the KT, or A equals PERT, and they also don't remember what happened a year ago, but they have a faint memory of the formula. Okay? We're going to use calculus to see where that formula came from and see the calculus connection to it right now. So, math models in which the rate of change of variable, and they use is the word proportional to the variable itself, are common in both business and scientific worlds. That's that concept of compound interest. That would be the business world. And in science, it's how things in nature grow or decay, whatever the thing in nature is that's growing or decaying. So it says, suppose that the rate of change of y. Y would be what the actual population is, right? So whatever that population is, y, how is it increasing proportional to itself? Let's say that you have, and it gives you that. So dy by dt means, how is the population changing with respect to time? Dy by dt means what? What's the rate, right? The population is changing with respect to time. Can be written as k times y. K, they use fancy words like constant of proportionality, which I can barely say, is the growth rate or decay rate of that population. It's growth if k is positive. It's decaying if k is negative. And y, again, is the population. So the rate is changing as a proportion with itself. So let's say the rate is 2. That means it's doubling, right? So 2 times y would mean that the rate, the growth, is doubling and you need a unit of time. That equation could be used with any unit of time. So if it was a day, a year, a month, an hour, whatever, it's doubling every, whatever the unit of time is. I need you to see the pre-cal to it, and now we're going to do the calculus. So what does dy by dt mean? The population, the rate of the population changing, right, with respect to time. K is a constant. It's the rate it's growing or decaying at, right? Usually a decimal. And it wouldn't be written, sometimes it's given as a percent, like it's growing at 10%, but you have to write it as a decimal. If it's positive, it's growing. If it's negative, it's decaying. And y is just the population of what it began with. Got it? Maybe? Here we go. So it says, take that. By the way, that in a box is called a differential equation. Did you know that? Diff-EQ? So if you had dy by dt equals k times t, what kind of equation is that? That's right, you can talk to me on the video. It's a differential equation, right? Or diff-EQ. Yeah. What happened?
Was that a problem on the last one?
Was it?
Oh, yeah.
Awesome. I'll be honest, I don't always go through every single question in the assignment because it's already done for you in the other packet. So I wait for you to talk to me and say, oh, please go over this again. And then I do. So it could be, did you do this question?
Yeah.
Or you didn't get to it? Number 7, Candy's like on it. Here we go. How do I know what y equals? What do I do first? What do I do to get y by itself? How do I solve this stiffy q? What do I do first? By dt. Notice it's not an x, you got to get over it. So multiply everything by dt. Do the work. When you put pen to paper, you actually keep moving with your brain. So what would that be then? dy equals kt dt. What would you do next? That's right. What are the two variables? K is not a variable. K is a constant. So what are the variables? Y and t. Beautiful. They're already separated. The t's are on one side. The y's on the other side. K is just a constant. What do you do next? What's the integration of dy? Y. In other words, if you just integrated 1, because 1, it's like 1 dy, right? What's the how would you integrate 1? Well, the answer would be y. What's the derivative of y? 1. Yeah? Maybe? Okay. Remember, k is a constant. That's like saying 2t, whatever. How would you integrate it? Add 1 to what? Okay, so it's now what? Mm-hmm. Where did I get it? T, right? From? Yes! Silly. If I knew how to edit the video, I would, but I don't. So, let's start with the correct equation. It was not kt. It's ky. Silliness, Mr. Gertson. Someone will have to teach me to edit it, and you wouldn't even think I made a mistake. Let's try again. What? You can't even see it. I scratched it all up. Okay, let's do the work again. First step is to multiply everything by dt, and then separate the variables. Well, now you got to separate them. So how would I get the y's to one side? It's not making the mistake. It's knowing you made the mistake, right? And going back and then making it right. Yay, lesson for today. All right, now what do I do? Integrate it. So now what's the integration of 1 over y? Yay. K is just a variable, like t or t, like 2 or 5 or 20 or whatever. So when you integrate it, what would it be? Kt. Good. And then? That's it. Never forget it. How do I get y by itself? How do I write this exponentially? Notice that even I get sloppy where the t and the plus sign starts to look very similar. Try to be nice. That's why I have a cute little leg on the bottom of my some t's and not make it look like a plus sign. We know this algebra, right? That we can then write that and just redefine the constant in front. And then to get y by itself, it could be plus or minus. And again, we could redefine that again, that constant. And now we have what it is. Do you see PERT, if you remember from a year ago? Do you see NE to the KT? Where N, that C2, is the initial population. K is a growth or decay rate, and T is time. So last year, you might have seen this formula, or you might have seen this formula, right, for business and science. That's connected to that. Where C2 is that constant. That constant in front is the initial population, or whatever we're talking about. All right, let's go down. Here it is, right here, right, in the box. That's called the exponential growth or decay model. So that means in nature, if there is a continuous growth or decay, in other words, the compounding is continuous. It's just, in other words, you calculate the growth, put it back in, calculate the growth, put it back in. And it happens constantly. You don't stop. That's the model. So let's look at what each variable stands for. What does C stand for? The initial value, whatever you're talking about. If it's money, or if it's something in nature, or a population of something. K is the growth or decay rate, and you write it as a decimal, even though it'll likely be given to you as a percent. T is the variable for time, and that could be any unit of time. And Y is the end population, if you like, the end amount, right after you do the calculating, whatever it is. So let's practice using that equation. It says, what is the rate of growth of the population in a city whose population triples every 100 years? And it says, assume the population growth can be modeled by this equation, that exponential growth model, and express your answer as a percent, rounded to the nearest hundredth of a percent. So let's annotate it a bit. So first you're asking for what? What is the rate? What's my unknown? Y equals CE to the KT. What letter do I not know? What variable? Rate is the K. That's what I'm looking for. In a city whose population does what? Triples every what? 100 years. Okay. So I'm going to start with Y equals NE to the KT. N is the initial population of the city. Are you given that? Do you know what the initial population of the city is? No. 0, that'd be tough, right? That'd be no city. So, but are you given the initial population of the city? No. What are you told instead?
It increases.
No. It triples. It does increase, but how does it increase? It triples, right? Every 100 years. So, what do I put down for the N and the Y, because I don't have exact values for that city? If I did, I would put in the initial being N, and then I'd triple it, right, for whatever it would be at the end. I don't know. So that means you have a choice. You ready? You can pick whatever you want the starting value to be, and then you triple it on the other side. Guess what I am going to pick for my population, because I don't hate myself. And if I triple it, what is now the population? So you can't have a population of 1, you can't have a population of 0. What do I not know? K. And then T is how many years? And what do I need to do is solve for K, and that's what it's asking for. So how do I get K by itself? First of all, 1 times anything, it's just e to the 100K. Well, you're going to have to. I'm going to ask that simple question. How do I solve an exponential equation? Is I write it as a logarithm, unless you can create common bases, which you can't. So how do I write this as a logarithm? What's in the exponent? Thank you. I like how you said that. All right, what logarithm has a base of e? What logarithm has a base of e? We're changing the form of this to a logarithm to solve the equation. Got it? Like what we did before the other way. We had a logarithm and changed it exponentially. Now we have something exponential and we're writing it as a logarithm. All right, the exponent is 100K. What logarithm has a base of e? Ln. And then what goes inside the logarithm? 3. And I don't need parentheses. But if I had something more than that, then it's all together inside. How do I get K by itself? Divide by 100, and now use your calculator. Ln 3 divided by 100. Notice again, you're going to have to go Control and Enter to get the decimal. If you just press Enter, it won't give you a decimal. Control and then Enter. And it says round the percent to the nearest hundredth. Do you see that? If I'm going to do that, the decimal actually needs to be 2 more than what I need, right? So this is what I see. Oh my God, do you see that? 0.010986? How do I change that to a percent? What do I do? Move it what? 2 to the right. And then if I moved it to the right, what would the percent be from here? It would be 1 point. Now 0.98 means the 8 makes the 9 go up. So really, to the nearest hundredth, it would be 1.10%. Just moving the decimal 2 to the right. So what is the growth rate of that town? And the answer is 1.10%. All right, turn the page. Here we go. Let Y represent the mass in pounds of a radioactive element whose half-life is 4,000 years. If there are 200 pounds of element in an inactive mine, how much will still remain in 1,000 years? And express your answer to 3 or more decimal place accurately. Okay. First of all, what does half-life mean?
Exponential decay?
No. Half-life means that something is decaying. Decaying means it's getting smaller. Half-life means the amount of time it takes to become half its size. So when you're told it's half-life, you're already told that it's decaying. And half-life means how long it takes to become half its size. Yes? It's there. We're going to start with y equals ne to the kt. How much are we beginning with? If it becomes half its size, what does it now become at the end? So n is the initial amount. Our initial amount is 200. What's half of 200? That's half the size. How long does it take to become half the size? Do you know?
4,000.
It says 4,000 years, right? That's a very stable substance. Things that decay very quickly, like radioactive stuff that's not radioactive anymore, go like in hours or days, right? Become half its size. That's where you get energy from. That's where you get nuclear energy and bombs and stuff. Things that are like this stable are good in a sense, but it's different. All right, how do I get k by itself? What do I do first? Divide by 200. I want to get e by itself first. What's 100 divided by 200? 1/2. How do I solve an exponential equation? I write it as a logarithm. How do I write this as a logarithm? What's in the exponent? 4,000, right? Thank you. 4,000k. What logarithm has a base of e? And what goes inside the logarithm? So to get k by itself, what do you divide by both sides? And now use your calculator. You should expect this answer better be negative, right? Because it's decaying. So ln 1/2 divided by 4,000. It's okay to put in 0.5. Now I'm going to ask for your help. Do you know, because I'm asking an honest question, how to put something in the memory of the calculator? I'm going to find out by next class. But one of the things we need to realize is that we can't round before the end answer on these AP exams. So if it's the very end answer, then you round it. But if you're in the middle of a question, you have to take the full number and have the ability with your calculator to save that number and then put it back in to what you're using. So you're not using a rounded number, but the full number.
Copy and paste?
Is there a copy and paste?
Yeah, like go up and
So I highlighted it.
control menu.
Control menu. Control menu. And it says copy, right? I'm just going to go for it. Candelaria is so awesome. Now, it's there, right? And when I want to put it back in, I'm just going to go Control Enter and paste, right? Can you see what I just said, the importance of an AP exam where you can't round in the middle of the question? Yes, yes? And that we need the ability to be able to copy the full number. We don't even see, right? That long number. It's in the calculator. And then when we need to use it again, we're going to paste it in. And then the end answer, we're going to round to 3 decimal places unless it tells us otherwise.
Put a highlighter and press enter.
You highlight it and press enter, and it gives you the same option? Awesome, Krusha. All right, here we go. Now, on my page, I'm just going to round approximately what it is. Negative 0.00017, right? But we know it's way more decimals than that, and it's saved on our computer, calculator. Now what do? Again, I write down y equals ne to the kt. Now I write down, again, how much is there originally of the substance? 200. Now I know the decay rate, negative 0.00017. Even though I'm not going to use that number, I'm going to paste in the exact long number, right? T, it says, how much will still remain in how many years? These questions require 2 steps. If you don't know the decay rate, you have to find K first and then use the rate to then answer what you're looking for. This didn't give you what K was. If you don't know K, you solve for K first, then there's a second step to solve what you're looking for. All right, the good news is there's no algebra here. Now it's plug and chug. So there it is, ready for your calculator. Plug that in. Let's see if this works. So in other words, I'm going to go 200 E. And now, what am I going to do?
Control menu.
Control menu, and then what? Paste. See how that whole number went in there? Then you're going to go times what number? 1,000. Here. Can you see that? All right. Now, again, I'm going to go Control and Enter to make it a decimal. And it says, express your answer to 3, right? What's the key number if it doesn't tell you anything in an AP exam? It's 3, right, after the decimal. But it's not 3 in the middle of the question. It's 3 at the end of the question. So what number am I going to put in? 168.179. And we have a unit. It's in pounds, right? So how much of the substance is remaining after 1,000 years? So we used half-life to get the K. Then once we knew what the decay rate was, then we found what we're looking for. Don't worry, there's lots of questions for you to practice. Example number 4. Last one. In pre-calculus last year, I don't know if I got to this. Did we talk about Newton's law of cooling last year?
Yeah.
Hooray! Here we go. We're going to see the calculus in Newton's law of cooling rather than just be given a formula. Newton's law of cooling states that the rate of change in the temperature of an object is proportional to the difference between the temperature of the object and the temperature of its surroundings. Suppose a metal figurine heated to 150 degrees Fahrenheit is brought into a room having a constant temperature of 72 degrees. If the figurine cools from 150 to 120 in 15 minutes, how long will it take for the figurine to reach a temperature of 100 degrees, and then let y equal the temperature? So we're going to go one step at a time. There's a lot of information there. We're going to start with the Diffie Q. Isn't that cute? What's the Diffie Q in this case? It says let. Does it tell you what letter you're going to use? I'm going to use Y. Y is going to represent the temperature. And you know why I didn't use T for temperature? Because it's changing with respect to time. Now I got T and T. That's just way too much for me. So it's dy by dt represents what in this case?
The temperature.
The temperature. So dy by dt represents what in this case? dy by dt represents what in this case? So it's dy by dt represents what in this case? 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 dy by dt represents what in this the change of temperature with respect to time. What rate is that, right? How is the temperature changing with respect to time? What does dy by dt represent, right? You got it? Now it says it is proportional, right, to itself. And they said the word difference. Do you see that? That means there's some kind of rate. If the temperature is decreasing, like it's getting cooler over time, K is going to be negative. If the temperature is increasing over time, K is going to be positive. And it said the difference. Well, the temperature we have, again, what letter do we use for the temperature in this case? Y. And it says the difference between that and the temperature of the surroundings. So when I read the question carefully, what's the surrounding temperature in the room? Right here. No, 150 is what the actual object is. What's the surrounding temperature in the room it gets brought into? So it's the difference between the temperature of the object and whatever the surrounding temperature is. That's why it's y subtract 72. Subtract, difference. Guess what we're going to do? We're going to solve the diffie-q. Let's do it. What do I do first? Multiply everything by dt. And because you're so smart, we're also going to divide by y minus 72 so that we can not only do that, we're separating the variables. So I multiplied everything by dt, and then I divided by y minus 72 to get the y's on one side and the t's on the other side. K is not a variable. K is a constant. Integrate. What does it look like? How do I integrate that? 1 over y minus that. Ln y minus that, right? And on the other side is just kt plus the constant. How do I get y by itself? And it's e to the kt. You know enough that we can then change the value of the constant, right? And it'd be a product in front. To get y by itself, what would I do? All right, can we solve for the constant? So what do I know? So we'll start. What's the initial temperature? 150. So y is going to be 150. Because I said initial, that means time is 0. So initial means 0, right? Before the time starts timing off. E to the 0 is what number? E to the 0 is 1. So C1 times 1. So how do I get the constant by itself? Just subtract 72. What's 150 subtract 72? You can use a calculator if you want. It is what? 78. So what's the equation we're going to use? Next, how do I solve for k? What else do I know? I need another information. The initial was 152. Am I given something else later in time where I know what the temperature is now? Do you see this right here? 120 and how many minutes? I need that. So now what's the temperature of the object? 120. I don't know what k is. I'm solving for k. How much time went by? What's t? So t is what number? And now I'm going to solve for k. How do I get k by itself? What's the first step? So what's 120 take away 72? Beautiful. What would I do next? Divide by what? Do it. Leave it as a fraction. Don't write it as a decimal. How do I solve that exponential equation? So what would it be? And then to get k by itself, what would you do? And what we're going to do, because Kendall already taught us this, and Krusha, we're going to save it in our calculator, okay? So it is ln 48 over 78 divided by 15. So I'm going to go Control Enter. I'm going to highlight over it. And then you said I could just press Enter?
Yeah.
No, it didn't do it for me.
I did. Did you highlight the whole number?
I did. And I press Enter, and then the number just popped down below, the same one. You know? I press Enter, and then it didn't do that. So I'm going to go Control Menu and copy. Maybe my calculator set up differently.
No, it's because when you highlight it and push enter, it just copies it straight down.
That's what I thought, right? It just goes down?
Well, it makes sense if you're in the middle, type in an equation, and then just go up and then push enter, it'll type it right where you're.
Got it. Okay, that makes sense too. So you could actually type in what you're typing in next, and when you get to that point, go back up, press enter, and it'll just bring it back down? Okay, so, good, it's in there. So it's about what? Negative 0.03, right? That's fine. Next, now that I know what k is, right, this is what k is, you think we're done. We're almost done. Do you remember this equation, right? Or was it? No, this one. This one. You remember that one? Because we know the constant, right? In there. Do you remember this one I just circled? Now we can actually answer the question because we know what the rate is. So it says, how long will it take for the figurine to reach the temperature of what? All right. So we're going to use this equation. So that means y again is 100. K is negative 0.032. I don't know t. That makes me sad because I need to do algebra now to get t by itself rather than just plugging it in my calculator and get an answer. Plus 72. I got to solve for t, and that will give me my end answer. Isn't that exciting? So how do I get t by itself? Step 1. What's 100 take away 72? 28. 28, that's right, 28. And then what would I divide by? So it's 28 over 78. Leave it alone. How do I solve for t? Exponentially, write it as a logarithm. How do I do that? What's in the exponent? Negative 0.032t. What logarithm has a base of e? Ln. And then what goes inside that? 28 over. What's the last step to get t by itself? Divide, and now use your calculator. All right, ln 28. Let me get down. There it is. All right, ln 28 over 78 divided by, now what am I going to do here after I divide? I'm going to paste, right? So I'm going to go Control Menu, and I'm going to paste in. And you're right, at this point, if I went up and highlighted, it would just put it right back in, right? Where I needed it. So that can be handy, right? Less steps. And then Control Enter. And it's in minutes. How many minutes would it take for it to go down to 100 degrees? It says round to the nearest minute. So it tells me, right? If it didn't tell me, I have to use 3 decimals, right? It tells me. So if I round it, approximately, how many minutes would it take? And the answer is 32 minutes. Beautiful.